Hello, Mr. Sutton here, bringing you the Pre-Cal Honors 7-1 Part 1 homework solutions on graphing conic sections. To graph this function, we're going to be graphing a semicircle because we've got the square root of something squared. So let's start by making it look like a circle. We can square both sides to get rid of that square root. So that's y squared equals 16 minus x plus 4 squared. And then if we just add this squared parentheses to the left side, now we have something that looks like a circle, with a center of negative 4, 0, and a radius of square root of 16, or 4. Now, which half of the circle are we graphing? We have y equals a positive square root. The y tells us it's an up-down sort of deal. The positive tells us we are graphing the top half of the circle. So let's go ahead and do that. And I'll make my grid lines go by 2s just so I can fit everything. So center, we had negative 4, 0 right there. And now if I'm graphing the top half, I'm going left 4, up 4, and right 4. I'm not going to go down 4 because I don't want the bottom half of the circle, just the top half, like so. And we're done. On this problem, we have something in circle form, so let's graph one of those. So our center, we've got negative 3, negative 2. Radius is going to be the square root of 4, so that's going to be 2. And let's do our center. We've got negative 3, negative 2. That's going to be right there. We're going radius 2 in every direction, so up 2, right 2, down 2, and left 2, and graphing that whole thing out. For this problem, since I just have a variable to the first power equaling a square root, this is going to be a semicircle. So to graph this, I need to start by squaring both sides. So I've got x squared equals 16 minus y minus 5 quantities squared. And then I'll have to add the y minus 5 squared to the other side. So now this is the equation of a circle right here, but I'm just going to graph half of it. But let's get the center. That's going to be 0, 5. And my radius is the square root of 16, which is going to be 4. So if I'm going 0, 5 here and then trying to go 4 in every direction, I'm probably not going to have enough room to fit all of this. So let me start by actually changing the scale of this graph. I'm going to make this 2 in each direction. And before I do that, actually, let me figure out which half I'm graphing. Since we have x equals a negative square root, that means it's going to be the left side of a circle. Left because it's right because it's x, and negative means the left side. So we're doing the left half of a circle. So changing my scale to go 2 for each grid line, I'm going 0, 5 for my center, and the left half of a circle, so I'm going to do 4 up, 4 to the left, 4 down, and here's my left side semicircle. For this question, I've got something squared plus something squared with no fractions and something that's not a 1 over here. So this is definitely a circle with a center of 4, 1. Now the radius is just going to be the square root of 9, which is 3. So I have a center of 4, 1. Now if I go 3 in every direction from there, I'm going to be off the grid. So I actually need to make a scale of 2 for all the grid lines. So now 4, 1 is going to be right about here. And I'm going 3 in every direction. So 3 up, 3 to the right, 3 down, 3 to the left, and connect the dots. There's our circle. On this problem, I have a single power variable equaling a square root, so this is a semicircle. To graph this, I need to turn it into a circle-looking kind of equation, so I'm going to square both sides to start that process. That'll be x squared equals 9 minus y squared, and then I'm going to add the y squared to the other side. So this is now the equation of a circle. We have a center of 0, 0, and a radius of square root of 9, which is 3. But I'm not going to graph the whole circle. I'm just going to graph half of it. Since I have x equals a positive radical, that means I am graphing left, right. I'm going to graph, since it's positive, the right half of the circle. And let me just check my scale. I'm at 0, 0. I'm going 3 in every direction. So a scale of 1 works fine for this. So there's our center. And if I'm graphing the right half of the circle, I need to go 3 up, 3 to the right, and 3 down, and connect those dots to give me a semicircle. On this problem, we're trying to graph this circle. So we've got a center of 3, negative 2. And then we have a radius of the square root of 4 here, so that'll be a radius of 2. Now if I go over 3 and down 2, and I go 2 in each direction, that's not going to go off my graph here, so I can still use a scale of 1. So we have 3 comma negative 2 center, and then we've got 2 in every direction. So I'm going up 2, right 2, down 2, left 2, and connecting the dots. For this next one, I have y or x something equals a square root, so this is going to be a semicircle. To graph this, I need to make it look like a circle and then just graph half of it. So I'm going to start by squaring both sides of this. That'll give me y squared equals, and then I'll just have 16 minus x minus 5 squared. Next, I move that x minus 5 squared over to the left side. And now this is a circle-ish kind of formula. So the center of this, if it were a circle, would be 5 comma 0. This is really y minus 0 squared. And the radius would be the square root of 16, which is 4. So the question is, what direction am I going with this circle? Since I have y equals, it's an up-down sort of semicircle, so either the top or the bottom of a circle. And since it equals a negative radical, that means this is going to be the bottom half of a circle. So I've got my center, 5 comma 0. That's going to be all the way over here, and then I'd be going 4 in every direction. I'm not going to be able to fit that on here, so I actually need a scale of 2 points per grid line. So the grid lines are all going by 2s, just so I can fit all of this. So using that, I've got 5 comma 0 right here. And then if I'm doing the bottom half of a circle, I need to do 4 to the left, 4 down, and then 4 to the right, and there's your half circle.